more deterioration, and so on, until you find that you reach your service life and you cannot use the structure anymore and the concrete spoil and all that stuff. How can we deal with that? We need to reach it somewhere here. Somewhere here. Don't want to wait to start, assessing my structure here, because it will need a lot of effort to get it up again. If we go to now types of repair, you have a problem and you need to repair it. The most famous one is the skin repair. Then we have injection for cracks. We have grouting, stitching, and we have enlargement of section. We have exterior pre-stressing, and we have shotcrete. We have a lot of issues related to repair. If we go to strengthening, and maybe some engineers deal with repair and strengthening as a one unit, or as a one phenomenon. Repair means that you have a problem, you need to rectify it. But strengthening, the structure is still okay, but I need to increase its capacity in order to enhance more and more, maybe because of the change of purpose of extra loads, or what we have mentioned before. The first system of strengthening is to enlarge the section. Enlarge the section means you have a structure with a certain dimension, you increase the dimension of it. A lot of details required. You need to anchor that concrete with that concrete, so you need to have shear anchors. You need to design the new concrete with the internal concrete to be as a one homogeneous section, and find the capacity of it. The other one is composite construction, to make steel plates, steel rods, and increase the capacity. This is, for example, if we need to increase the bunching. This one is another solution of strengthening, is to reduce the strengths, the stresses. For example, if you have you make a cut and you make here a joint rather than having continuous, although I don't like it a little bit, but it is one of the solutions for strengthening. External pre-stressing, if you have a problem of shear, you can make rods and tighten it in a way to make external pre-stressing. Recasting, or increasing the thickness by casting concrete. This is the way of casting concrete. This is shotcrete. And this is the shotcrete, and there are two types of shotcrete. One is dry, and one is the wet. This is enlargement of columns, either enlargement by concrete or make a steel plates. This is the steel jacket. This is another steel jacket. And then we can have grout between the steel jacket and the concrete. This is enlargement to solve the issue of bunching, either by concrete or by steel. You can see here. Again, enlargement with the steel. Collar, you can get it into pieces, just put it there and make bolts. Or steel plates, tie it together. Or enlargement of the columns to avoid punching of slabs. Or another solution which is very easy. To connect these two columns together, instead of having block wall, we're going to make it concrete. So that will enhance the capacity of the structure. Beam strengthening and slabs, either by enlargement of beams or having the enlargement of beams can be all through if you have overlay, or it will be three sides, like you can see here, with anchor. Enlargement of slabs can be overlay or enlargement from bottom. Steel plates can be used like this to enhance the capacity of the structure, either by bolts like this or through bolts. Foundation strength by increasing the dimensions. Or another solution by reducing the stresses. If you have a large span, you can reduce the span, so that will reduce the bending moments, or having more supports. Increasing the capacity by adding more piles. External pre-stressing to close these kind of cracks happen in a beam. This is a lot of famous issues, double cantilever carrying a bridge, and you start having cracks like that, so you can make external pre-stressing. Or if you have a beam like that and you have a problem with deflection, you can make also external pre-stressing by having a pivot and pre-stress it from here and there. This is an example of external pre-stressing. This is also external pre-stressing. If you have shear problem, like cracks like this, you can add some rods, either by insert or external like that. This is the way of application, either vertical or inclined. Then you can cast the concrete or leave it outside as a pre-stressed. This is outside. Close the shear crack. And then came by 1980 something an introduction to the construction market to use what is called FRPs. FRPs is used a lot for, but not in our field, not in the construction. And we're going to find out why now. By that time, a lot of research had been done in order to introduce the carbon fiber, glass fiber, and Arabic fiber in the market of construction. If you can see the stress strain curve for the steel that we are using and the GFRP, AFRP, CFRP. Our steel that we are using more or less is 460 or 500 megapascal. This is the either yield strength or ultimate strength, a little bit 600 or something. But if we talk about carbon fiber, instead of 600, 400 or 460 here, we are talking about 3,000, 3,050, 500. We are talking about glass, 1,500. Aramid, around 100, 1,700. Oh my God, that's huge. But we have two issues we need to consider. First of all, the steel is ductile. The CFRP is brittle. The CFRP having the same Young's modulus almost, like the steel, but the glass having a very weak Young's modulus compared to the steel. The Aramid is something in between. Why it is not used before? Let us see the price. In 1970s, the pound of carbon fiber is $150. But that's expensive for us at the construction. So they use it in rockets. By 1980, it goes down to $65. So they start using it in aeroplanes. In 1988, 90s, they use it for skiing, equipment or whatever. And then after that is getting lower and lower. $10, yeah, can work, construction, cheap issues. Then we can use it here. And start to construct from that time to go more and more in our construction field. Nowadays you have a full car CFRP. Anyway, and more, you know, a lot of consumption all over the world of the CFRP, and the price is getting less and less. Let us compare structure that we need to strengthen in 1960 and strengthen that we need to strengthen now. In 1960, the consultant would say, I will put a steel plate like this, either from bottom or from the side, to resist shear or to resist bending, and that will enhance the beam. But nowadays, nobody uses it. Nowadays, they are using CFR. Okay? Why? Let us compare. If we use a steel plate, you have a low material cost because it is less price compared to the CFRP or composite. But it has high installation cost. A lot of people, a lot of equipment need to carry the structure, the steel plate, because it is heavy. We have a problem with corrosion with time. We have a problem of fabrication. We need to somehow cut it and, you know, do it with the devices in order to get the size. Compared to the composite, low installation cost, 1 or 2 can install the plate. It's very light, no corrosion, lightweight, no fabrication required. You will get the roll and cut it and install it. But the issue is low maintenance here, because you will leave it and that's it. And you will have high maintenance here in order to protect it from corrosion and so on. So here you will pay less here, and with time you will pay a lot. Here you will pay a little bit more here, but after that you're not going to pay much. The CFRP all over in the construction field, they use it in 3 shapes. The first shape, they made rods like this. They have glass rod and they have carbon rods. The carbon rod is expensive than the glass rod, but both of them are there in the market. There are a lot of structures built with that. Bridges, also in Europe, in Canada, in the States. But I haven't seen the Gulf here. They start using it in the construction as a new construction. The other shape is they made composite like cross sections, like to replace the steel. So this angle is glass fiber. This I-beam is glass fiber. So if you are using it in a steel structure building in the desert, and you have a harsh environment there, instead of building it with steel, forget about the steel, not going to have any corrosion, and you can get these sections and build your structure with it. It will live forever, because you don't have corrosion anymore. This is the second. And the third one is strips and sheets like that. And we use both of them in repair and strength. So this is mainly in our construction field now, which is the strips and wrap like this. As far as I know, Engineer Omar, yes, you will add it to your group of, you know.
It already exists and will be introduced in Saudi Arabia by beginning of 2024.
Okay, so an announcement. Fisher will have CFRP strips and wrap starting for 2024. And also definitely will be in United Arab Emirates, Qatar, Bahrain, and so on. In order to get an idea how we can use the CFRP in construction, repair, and strengthening, you can see here that these strips are glued to the concrete as if you add some extra reinforcement. instead of having, for example, 5T16, I will add to it another 4 or 5 T16 or T20 or whatever the amount of needed. Then you increase the capacity of the slab with the amount of steel, but without inserting it inside. You have a problem of stirrups here. You don't have a lot of stirrups required, and you check your beam, the beam is unsafe. I need to increase the capacity of it, so I will apply wrapping of CFRP, so that if I added 1 or 2 stirrups required more. You have a problem of negative reinforcement at the columns, either this direction or that direction, then you can add strips like this. Even if you have your blocks, you can just remove part of it, pass the strips, and then rebuild it again. So application-wise, it's very simple. From the first impression, everybody can do it, but take care. 50% of this issue is the application. So if I glue it with the concrete not proper, this means I did nothing. So I need to make sure that it will be glued with the concrete in a proper way. That's why all manufacturers of CFRP, they issue certificates for specific applicators that they will well trained that they can do that. Otherwise, it is a disaster. Because if you apply it, you imagine that it is working, it is not working, then you did nothing. So it's very important to assure that who will apply the CFRP 50% to make sure that this place in the concrete is already well studied, prepared for the surface preparation. So the surface preparation in the area where you apply the carbon fiber is accepted. You will put enough glue, specific glue, come with the CFRP as a 1 unit. Time-wise, what's the break? We should have a break. We need a break? Yes. Okay, so quickly I will cover this and then continue after break. So, the beauty of that, even if you have the MEP equipment there, you know, the sheets, the strips are very flexible, so you can just, you know, apply it without even you need to remove all the equipment. So the beauty is that you need to remove everything, and then in order to apply the strips, this is the application for shear, application for columns. If you have a column like that, and the capacity is not safe, you can increase the capacity of the column by CFRP wrapping. I will summarize here. We can do wrapping of columns to increase the capacity. We can have negative reinforcement. We can have positive reinforcement. We can have shear. We can enhance the openings. So if you need to make a new opening, you can put CFRP around. You can increase the capacity of the slab from bottom or from top. Even for earthquake, you can use it as an application, either on the concrete or even on the blocks. I will stop here. I'm going to leave this video after the break. I don't know what is the coming issue.